People are scared of fractions. I know that's the case. But we did fractions in this course already, so fractions will continue to come up. And part of the reason why people continue to struggle with fractions is because they're scared of them and they avoid them. And people continue to say, I don't know how to do fractions, I don't know how to do fractions. I can tell you from experience, fractions are not that bad once it clicks. All of a sudden you're like, oh my gosh, I get it now. And it's not that bad. But it just takes practice, it just takes time. That being said, the good news is, when we're solving equations with fractions, we're actually barely working with fractions. Okay? So our first step, we're going to get rid of the fractions, and then we just have some other equation to solve. So if you do it correctly, after your first step, you will have no fractions left. So we don't actually have to do fraction math. When you're doing a check, then you might have to. Usually the fractions work out anyway, so it won't be too bad. But if you're doing a check, then you might have to do a bit of fraction math. But I'll tell you, usually in this process, it's not actually a lot of fraction math. Adding fractions that have strange denominators, multiplying fractions, we don't have to do very much of that, if any. Okay, so that's the good news. And that's what this blurb says. And if you ever forget how to solve an equation with fractions, I say 3 things about it. I think it's 3 things. You pick a number. What number? The lowest common multiple. It's like a common denominator. It's not a common denominator, but it's like as if you were finding the common denominator. Okay, lowest common multiple. And multiply it by everything. And why do we do that? To clear the denominator. So that's my 3-part statement of how you solve equations with fractions. Find the right number, multiply everything by that number, and that clears the fractions. And then we're all happy, no more fractions. Does that sound good? Let's try it with this first one. X over 2 plus 1 equals x over 3. Can anybody solve this by inspection? I didn't think so. So we need to know what steps in order to solve. So if those were regular fractions, like in our fractions unit, and you were going to add them together with a common denominator, what would be your common denominator? I bet everybody in here knows it. Caleb? 6. Anything bigger would work. You could use 12. You could use 18. You could use, what's a nice big one? I don't know. 300. 24 is a good one. You could use 300. I don't know why you would. That's just going to make your life way harder. It'll work, but the lowest is going to be best. So we're going to multiply everything by 6. I'm going to write that off to the side, times by 6, but we're going to show it in our next step. Okay? And when I say everything, I mean everything. Some people think, well, that one doesn't have a denominator, so I don't have to multiply it by 6. But this is equations. Whatever you do to one side, you do the same to the other side. So I multiply this whole side by 6, which means I multiply every part of it by 6. So what does it look like? It looks like 6 times x over 2 plus 6 times 1 equals, and same on the other side, 6 times x over 3. Easy enough? Now what I think you should do, and the whole point of this is you picked this number so that this will work. If you pick a common multiple, it'll always divide with everything. So what is 6 divided by 2? 6 divided by 2 is 3. And that works out to 3x. No fraction. If you have a fraction left, you've done something wrong. 6 times 1. Can anybody do that? Get your calculator. 6 times 1, 6. 6 divided by 3 is 2. And so what do I have left there? 2x. See how easy this is? It gets a little bit harder, but it's not much. Okay. Our rule, now what do we have? We have a multi-step equation. Variables on both sides. Our rule is letters equals numbers. So letters on the left, numbers on the right. This case, you might move the x to that side, because then you only have to move one thing. I'm going to do it the other way just to show you what it looks like. Because I think there was a question like this in the practice somewhere, and a few people did it wrong because they got themselves confused. Because sometimes questions change a little bit, we get ourselves confused. So I'm going to stick with that rule. Letters on the left, numbers on the right. Which means I'm moving the 2x. So I subtract 2x from both sides. And I'm moving the 6. So I subtract 6 from both sides. But I'm subtracting 6 from nothing. And some people worry about that, like you can't do that. Well, you can. Nothing is 0. 0 minus 6 is just negative 6. So it's fine. So this is 3x minus 2x. And this is 0 minus 6. So my answer is negative 6. Is that okay? What if I did it the other way? You don't have to write this down. Maybe it's better not to write down both, but it would look like this. I would have just moved the 3x, so minus 3x, minus 3x. And I would get 6. 2 minus 3 is negative. What's my next step? Yeah, divide by negative 1, or just flip it to the other side. As long as this is all I have left, I don't have any other junk, like a plus 7 or something on the end of one of these, I could just say then this is true. And I can be done. Again, don't stop there. Make sure you finish. Okay? That was something that people also do. They stop here. Make sure you finish. And it's the same answer. X equals negative 6. Negative 6 equals x. Same answer. Hey, look at that. 6 divided by 2. What was our answer? Negative 6. Negative 6 divided by 2 is negative 3. Plus 1 is negative 2. Negative 6 divided by 3 is negative 2. So it worked. I hope it worked. So what's different about this one is I have not just an x on top, but an x plus 2 and an x minus 1. So that makes it a little bit different. We need to kind of know how to deal with that. But once we know how to deal with that, we know how to deal with all of it. What's my first step? Figure out what the number is. What is the number? 12. What's my next step? What do I do with the 12? Yeah, we're going to multiply it through. Why? Why are we multiplying through? What's it going to accomplish? Uh-oh. It's okay, turn it off. See, this is important. You want to know what we're doing, how we're doing it, why we're doing it. When I multiply by 12, what will happen? Get rid of the fractions. They're going to be gone. Find the number, multiply by the number, fractions are gone. So we're going to multiply by 12. And I don't have any other stuff, so I'm just multiplying by 12 by both of these things. And again, remember, you pick the number. So if it doesn't work, that means you picked the wrong number. It's not like I did everything right and it didn't work this time. Mr. Belair's nuts. No, you picked the number. You must have picked the wrong number. Does 12 divided by 3, does that work? Yeah, 12 divided by 3 is 4. And it will work every time as long as you pick the right number. 12 divided by 4 is 3. So see, it worked. But now what do I do with these? What does it look like? So how would I write it? Yeah. There's something else that we need to be very careful of, though. This is 4 times the whole thing. How do we show that? I don't want to take away the brackets yet, You can do this in one step, but I'm going to keep the brackets like this, because isn't it 4 times the whole thing? So this is now the question like from yesterday. And now we're going to get rid of the brackets by multiplying, which you could do in one step. You don't have to show this. You can do 4 times x and 4 times 2 as long as you're doing it correctly. But this one becomes an equation with brackets. But again, we already know how to solve that from yesterday. So go ahead and try to solve this one. So I've expanded both brackets, and that's what I got. Check your answer. Again, what people forget is they forget to multiply by the second part. Even though you know you're supposed to, you forget to do it. So it's got to be 3 times negative 1, which is negative 3. Okay, then I am moving things around. Letters on the left, numbers on the right. 4x minus 3x is x. Sometimes people make these integer mistakes. Negative 3 minus 8 is negative 11. Any questions? What's happening in this one? It's a little bit different. Okay, yeah, all my x's are on the same side. Turns out that's not, I mean, that helps a little bit, but not going to help us too much. We still want to find out what x equals. There's 3 fractions, and one of them is just a number, doesn't have x. Does that matter? Yeah, that matters. We're gonna get rid of that as well. So we have no fractions at all. Remember the first example we did? We had a 1. And we still had to multiply by that. So same thing here, just because this is a number and not an x, we still have to multiply by it, but this time it's fraction and we want to clear that fraction. So I need to come up with a number, and turns out in this case it's not too bad, but that will clear all 3. So what will work for this one? 12 will work again, because 12 does 3 and 4, but 12 also does 2. If you multiplied all of them together, you get 24. 3 times 4 times 2 is 24. Bigger than you need to, it would work. I want you to go ahead and try that. Nice. So a lot of you are way ahead of me. So I've got that so far. And again, I've rewritten it as a distributive property question. But I did this part. 3 times 1 is 6. Everybody got the same thing, or most people have the same thing so far? Now I distribute 4 times x and 4 times 4. Don't forget to do that. Negative 3 times x. And be careful, negative 3 times negative 1. That's a place where you just make a little mistake. Should be positive 3. And I'm going to collect like terms on this side. 4x minus 3x is just x. 16 plus 3 is 19. Whoops. And then subtract 19 from both sides. 6 minus 19. Minus 13. Good. How's that feel? Not so bad, right? Everybody had this panic attack when I said fractions, or when you saw fractions. Oh, here we go again with fractions, but it's not that bad. If you remember, which today you probably will, but when this comes up later in the course, you're going to be like, oh, fractions, that's too hard. I don't know how to do it. It's not that bad. Find your number, multiply by your number, get rid of the fractions. You just have to remember that that's what you're doing. Okay, we're going to do one solve and check. Again, I'm going to give you a second to get this started and try it. Okay, so it's kind of interesting. I know not everybody's quite done yet, but take a look up here. As I walked around, I saw about half of you chose 8 and about half of you chose 4, and I didn't see anybody choose anything else, but maybe somebody chose something else. So that's interesting, and that's fine, and that's what I would expect, is that a lot of people would choose 8, a lot of people would choose 4. 4 is smaller. 4 will clear both. There's no reason why you have to use a number that's bigger than both, but don't erase what you did, because 8 is not a big deal. And it's interesting to see how that will change things if you do it differently. So 4 divided by 2 is 2. What's 4 divided by 4? 1. So it just means on that side, I don't have to do distributive property. So I end up with 2 times x plus 1, and then 1 times 29 minus x, which is just 29 minus x. There's no reason why you can't do that. But if you chose 8, you'd end up with a 4 here and a 2 here, and it's not that much different. Okay? So follow it through. Don't change your answer. Do it the way you did it and see if you get the right answer. That's what this is all about anyway. I'm going to move the 2. How do I move the x? It's already negative. So I'm going to add x. And you're looking at yours if you chose 8 and you're just noticing everything on yours is double mine. But that's still balanced. Remember what we said. As long as you do it to one side, you do it the same to both, it'll still be balanced. Double both sides, we're all good. Okay, so 2x plus x is 3x. 29 minus 2 is 27. So let me guess, if you chose 8, you had 6x equals 54. But then you get the same answer. Divide by 3, divide by 3, you get x equals 9. Right? You get the same thing. So no worries. You get yourself to the same place. And really, in this case, not much harder. If you use something that's way bigger, then you can be in trouble. So in this case, there's not really fraction math happening. Like I said, in most cases there isn't, but there might be a little bit here and there. I sub in 9, and then in BEDMAS, 9 plus 1, 10 over 2 is 5. Some people might leave that as a fraction because they think this is fractions, but no, 10 divided by 2, right? It's 5. So that's 20 over 4. Look at that, 5. Any questions?